What if I don't know how many variables I'm going to need? How do I efficiently store all the values the user has entered? Why do you tell us to start our loops at 0? This is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is video 40 in the Introductory Programming in Java full course and the first video of the final lesson, Lesson 7, Arrays and ArrayLists in Java. In today's video, we're going to introduce arrays, including how to efficiently access every element of an array with a loop. Let's jump right into it. Up until now, we've declared variables that hold either a single value, in the case of primitives such as int, bool, char, and double, or a reference to a single object in the case of strings, scanners, our own user-defined types, and other classes in the Java API. The value that a variable references can change over time as a program executes, but the variable can hold or reference only one value at a time. And quite often, we would like to be able to hold a large amount of data in memory. For example, we might want to read in a large table of data from a file and perform a statistical analysis on it, maybe reshape it all and then write it back out. Or we might have a program that allows the user to create objects such as shapes in a drawing program or slides in a presentation program. There's no way to know when we're writing the program exactly how many objects or shapes or slides the user wants to create. And we might not know how much data is in a file or how many files are in a directory. There is a programming language solution to this problem available in Java and many other languages called an array. An array is a data type that allows us to define a single variable that can reference a collection of values, for example, 100 names or 5 grades or 10 Boolean flags. A single array can hold any number of any single type of value. Let's look at an example of how we do this in Java. This program, called SimpleGrades.java, reads 5 grades from the console and stores them in an array on lines 16 to 25, and then reports whether each grade is passing or failing on lines 29 to 38. I'll run the program, and I'll enter 100, 80, 60, 40, 20, and the program reports that the first 3 are passing and the last 2 are failing. You can see the program obtained all of the data and then examined and reported on it after. Now, you might look at this and say, yes, but you could have used 5 separate variables. I don't see the benefit. That's because I want to focus on syntax first. By the end of the video, I'll have shown you a version of this program that uses loops. And with loops, we can write this program to read 5 grades or hundreds of grades, and it will be only a few lines of code. So you will see that this is really quite powerful. It allows us to store and manipulate a large amount of data with very little code. We don't even have to know exactly how much data there will be when we're writing the program. In our program, you can see we have one variable to store the 5 grades called grades. The variable is declared on line 7, but the data type might look a little unfamiliar, double followed by open and close square brackets. Remember, when we declare a variable, the syntax is data type followed by variable name. So double open close square bracket is the data type of the variable grades. When we follow a data type with square brackets, that means rather than declaring a variable that will hold a single value of that type, we're declaring an array of that type. So double open close square bracket means a double array, or an array in which each individual value is a double. Here are some other array data types. They all follow the same pattern. Int open close square bracket means an array of integers or whole numbers. Boolean open close square bracket means an array of Boolean or true and false values. String open close square bracket means an array of string references or text. We can even have arrays of our own programmer-defined data types. Die open close square brackets would be an array of die objects. We'll look at arrays of objects in detail in another video. I just want you to see that an array of objects is possible and is in fact very common and powerful. The declaration simply declares the variable. It tells Java that grades will be a reference to an array of double values. That allows Java to check that everywhere we use the variable, we're treating it like an array of doubles, so Java can throw a syntax error if we're not. Just as with my string variable pass or fail, it doesn't have any value until we assign a value to it with an assignment statement. We don't have an array yet. Arrays are objects, although like strings, Java has a little bit of syntactic sugar that makes them feel a little more primitive. But because an array is an object, we need to create it with the new keyword. Again, like strings, there is a shortcut that is sometimes useful, which I'll show you in a moment. Usually we'll use new. To create the array, we have the line grades equals new double open square bracket 5 close square bracket on line 13. Look at the syntax of the instantiation. We have the variable name on the left, grades, and then equals new. So far you've seen this before. And then double open square bracket, the integer 5, which is the size of the array, and then close square bracket, semicolon. So it's the same data type as before. Double is the type of data in the array, and then brackets. But inside the brackets, the size of the array. This will be an integer, but it doesn't have to be a literal. It can be an expression that evaluates to an integer, such as an integer variable, a constant, or even a mathematical expression. You can also put the variable declaration and instantiation all on one line. So double grades equals new double 5. However, we don't always know the size the array is going to be when we declare the variable. I want you to see the two parts, the variable declaration and the instantiation, as separate so you understand the function of each part. The line of code grades equals new double 5 allocates memory for an array of 5 doubles. As with all objects, a default constructor executes, allocating memory on the heap and giving the 5 doubles a default value of 0. The reference to the array in heap memory is stored on the stack in the grades variable. I have here a representation of the stack and the heap after the line of code grades equals new grades 5 has executed. This is to emphasize that the array is an object and is stored in dynamic or heap memory. I'm going to show you a more common, informal representation used for arrays, though. This representation can be very helpful when working through array algorithms. The array is represented as a series of distinct ordered boxes. Each one holds a value, and each one has an index. The values are shown inside the boxes, and the indices are shown either above or below the boxes. This drawing represents the array after initialization, with each box holding 0.0. The index is a number representing the position of the box in the order. The only catch is that we start indexing at 0, so the first box is at index 0, the second box is at index 1, etc., and the last box is at index length of the array minus 1. Our array has a size of 5, so the index of the last element is 4. The length of the array minus 1 will always be the index of the last element of an array. The entire array is referenced by the variable name, which is grades. We use the indices of the boxes to access the individual boxes. We write array name, open square bracket, index, close square bracket. So, for example, for the first box, we write grades, open square bracket, 0, close square bracket, and we read that as grades sub 0. Now, look in our code where we're assigning a value on line 17. We have grades sub 0 equals standardin.next double. We are assigning what the user has entered at the prompt to the first box in our array. If the user types 100 at the prompt, as I did, after this line of code executes, 100.0 will be stored in the first box in the array. I want to note a couple of things about this line of code. First, grades sub 0 is a double variable. The array grades is an array of double variables. If we index in, so grades sub 0, grades sub 1, etc., then those references are references to double variables. We can put them anywhere we put a double variable. When the variable is on the left of an assignment statement, we're referring to the box or location, just as when any variable is on the left of an assignment statement. We assign into all of the boxes in this way through line 25. On line 29, we're using the value of grades sub 0 in a test. Is the value in grades sub 0 greater than or equal to 60? When the variable array name sub index is in an expression, then we're referring to the value at the location, just as with any variable. I can put any double variable in an expression, and we're referring to the value, not the location. So in this code, we're using the ternary or conditional operator to set a string to either passing or failing. And then on the following line, we're interpolating the value in the array into a printf statement. Okay, that is the basics of the syntax, how we declare an array variable, allocate space for the array, assign into a location in the array, and access the value at a location in the array. Now let's talk about how to make this more efficient with a loop. Even though we have this single variable grades, which is holding 5 values, we still have to access individual locations in the array to get at each value. So it can hold a lot of data, but to store and process that data, we still need to methodically visit each location in the array, as you see here. But you might notice the repetition with a pattern of changing values. In lines 16 to 25, we repeatedly request a grade and then assign what the user types into a location in the array. The only thing that changes is the index. The index starts at 0, increments by 1, and ends at 4. The same with the lines in which we print whether each grade is passing or failing. We repeat the test and the print statement, and the only thing that's different is the index. And you know that a for loop can give us a series of values. We can write a loop that will generate those indices for us, so we don't need to repeat the code. Here's a version of the program written with a loop, called loopgrades.java. Notice that we have a loop around the 2 lines of code that read in the grades, so that code now takes only 4 lines, from 17 to 20, including the closing brace. And we have a loop around the 2 lines of code that test and print, again taking only 4 lines, including the closing brace, from lines 24 to 27. You can see that the indices within the code have been replaced with the loop control variable I. In the loop header, you can see I starts at 0, stops at grades.length, and is incremented by 1 each time through the loop. The variable grades.length is the name of the array variable .length. Length is a property that all arrays have, their size. In our example right now, that is 5 because we construct the array with a size of 5. I recommend always getting an array's length from the array itself. If I had hard-coded a 5 in each of my loops and then decided to read in a different number of grades, I would have to find all parts of the program in which the literal 5 refers to the array length and change them to the new length of my array. In addition, as you will see later in this lesson, we don't always know the size of an array, but the array always knows its size. This loop pattern is very common for iterating over an array. The pattern I equals 0, I less than array.length, I++ will always visit each element in the array exactly once. It will never accidentally try to access an element that doesn't exist, such as grade sub 5, resulting in an array index out of bounds error. And this is why it's a good habit to begin loops at 0 and go up to but not including the number of times you want the loop to execute. Loops are so often used to iterate over collection structures such as arrays that it will help you if you're already in the habit of writing a counting loop this way. Now suppose I want to read in 100 grades. If I change the size of the array where I construct it on line 14, then I now have an array of size 100. Nothing else needs to change. My loops will now iterate through the indices 0 to 99. I don't want to enter 100 values, but you get the idea. I can even ask the user how many grades they want to enter, store that value in a variable, and then use that variable to construct my array. I don't need to know when I'm writing the code how large that array is going to be. An array with a loop is an efficient way to store and process a large amount of data of the same type. I want to show you one other bit of syntactic sugar to finish this video. Our array initialization is here on line 14, grades equals new double 5. But we can initialize an array with a set of values instead of giving it a size by using curly braces and a comma-delimited set of values. To do this, though, we need to do it on the same line on which we declare it. So I can write double grades equals open curly brace 1, 2, 3, 4, 5, close curly brace. And that will declare and initialize the array at the same time with a set of predetermined values. These don't have to be literals. I can initialize the array with variables, constants, or more complex expressions. To summarize, we talked about the primary advantage of an array. You can store a large amount of data in one variable and easily process that data with a loop. We talked about the syntax of declaring an array, a data type followed by brackets, and 2 ways to construct an array, with curly braces and a list of expressions, or with the new keyword and a size in square brackets. We talked about how to access individual locations in an array and individual elements of an array with the variable name, open square bracket, index, close square bracket. We looked at a representation of how arrays are stored in the heap, as well as an informal diagram that is often used to help visualize array processing algorithms. We saw that an array can report its size with the length field, which we access by typing the array name dot length. We should always use this as the ending condition in a loop if we wish to visit every element in an array. In the next videos in this lesson, we'll look at more examples, including array processing algorithms, reading from a file into an array, multi-dimensional arrays, and arrays of objects. As always, I've included an auto-graded exercise in the description of this video so you can practice with the video code, and the 2 code examples are available in my GitHub repository with a link in the description. Once you're feeling confident with the concepts in this video, you're ready to move on. As always, have fun and keep coding.